Okay, so yesterday, and we're recording, so let's get it together. Yesterday we started by defining properties of a line segment. What makes a segment a segment?
No arrows.
If it stops, no arrows. Can it be measured? Yes. Now, how do we measure it? What do we use?
Ruler.
Or a
Protractor.
the straight edge of a protractor. Look at y'all looking at your notes. I'm so proud. And now we have this to help us figure out where the tick marks are, correct? And we're going to use it and not tell me that it's about 2.5 because we don't round. We use the tickies. No, because I'm not a cloud or an umbrella or an awning. Cloud. Okay, so what I want us to do now, at the end we talked about collinear, 2 or more points on the same line, and we also talked about betweenness, when a point or points on a line that lie between two other points, which makes sense, right? So what that actually is the segment addition postulate, and that's on 3B. So we are going to write down our segment addition postulate. What do you think that means?
It's addition of the segment.
Take a point. Look at you go. The addition of the segments to make up another segment. That's really what it is. And it's really that easy. So if I give you a segment, and I'm going to use the straight edge of a protractor or a ruler to make this segment, because I'm a real OG, and I'm going to call it S and okay.
Teacher, could we please have sophomores, P through Z, to the main lobby for pictures. P through Z, sophomore.
Okay.
Thank you.
So between this means that there would need to be a point in between those. So I'm going to put a, okay, thanks.
Everyone else got it.
Okay, open the door and let me, okay. Hello, new child. Sorry that we're like attacking you. All right, who has 4 people at their table?
We don't have, we just have, yeah.
We do? Okay, can you come sit back here? Can you tell me your name so I don't just call you new child? Jarvis? All right, I'll try to remember. We'll clean them off.
They're presents.
They're not a present. Hang on, it's going to be damp now. What are you whining about? Okay, so segment addition postulate means that we take the segments and we add them together. How many segments do you think are in this segment?
3.
3. Because we have 1, we have 2, and if we put them together, we get 3. Magic. So that's literally what the segment addition postulate says. It says point K. Oh, Blair, that's not how you spell point. Is between S and J if they are collinear and SK plus KJ must equal SJ. So it's basic stuff, right? If you add it together, you should be able to get the full part. Okay. That's all segment addition tells you. So now what we're going to do, before we do our handout and our activity, I want you to tell me, would you look at example 1 while I'll let us finish writing. I want you to tell me what AC is. Example 1. Alright, who can tell me what Justin, since you are just bent on talking, my love, tell me what AC is.
Yeah.
Why do you have to do that? How did you get that? Look at you go. Does everybody understand? Now, we just added them together. Did I say measure AC? No, I just said find AC, and I gave you AB, and I gave you BC, and you put it together like magic. Now let's look at example 2. What if I asked you to find DE? Look at you go. Could we call this X? We could. And we could say that X equals 26 minus 18. And what's 26 minus 18? What? No judgment. All God's children. 8. That's all you do. Okay. I need you to let it go. Move on. But if we're going to talk about last year, I'm upset that Josh is across the hall right now and hasn't spoken to me at all this year. So I need you to call him out on that. Yeah.
So 6th grade, I need to call down.
Oh, yes. All right, now let's skip to the bottom, and then we're going to do example 3 and 4 without, well, example 3 with me. Okay. All right, so this says, on a drawing, we mark congruent segments with dashes. Looking at this drawing, do you think that the top and bottom are congruent or the sides are congruent?
Sides.
So we put dashes. That's it. Going all kinds of fancy in geometry.
It looks like they have arms.
I know. Little T-Rex arms. All right, now, these are some vocabulary words that you're going to need to know. Drawings are made with rulers and protractors. Constructions are made with a compass and a straight edge. And I don't know why I made the line so small. And the last one is a sketch. If you don't use anything, it's called a sketch. So sketches are created without any of these. Now, looking at example 3, how do you think we would find the value of x? Put them equal to each other. Would we set 3x plus 4 equal to x?
No.
What would we do with it?
3x.
Equal to 5x minus.
We would set 3x plus 4 equal to 5x minus 10?
No. 3x.
Close.
3x plus 4 plus x equals 5x minus 10.
Take another point for your team. Add these together. It's the segment addition postulate. You add these together and then set it equal to this. So I'm going to come over here because I'm out of room on my paper. Did you say you're confused? Why?
I know he said it for some of it.
Alright, and I'm going to write example 3. Now, does everybody see why we're adding the parts together? Do you want me to show you again? Okay, so we know that AB is this one right here. And we know that BC is this guy right here. The whole thing is 5x minus 10. If you add these two together, it has to equal the whole thing, right? Isn't that what we did up here? 8 plus 18 has to equal 26, otherwise it doesn't match. So you have to be able to add these together to get the whole thing. So when we write it, I would write 3x plus 4 plus x equals 5x minus 10. Can I solve it from there? All right, do I have any like terms that I can combine? 3x and the x. So 3x plus x is 4x. Now what would I do? Okay. What's 5x minus 4x? Okay, now what would I do? Add 10. Look at us go. We are. And what does x equal? Magic. Now, did we do everything the question asked us? Go back and read the question. And AB. So do we know what AB is? 3x plus 4. So do we know what x is now? Okay, so what do we do? Look at us go. All right, we have 3x plus 4. Now I'm going to take what x is. I'm about to hurt y'all. Go away. Go away. All right, so we do 3 times what? 14. Plus 4. All right, what's 3 times 14? We'll pick it up, baby. And 42 plus 4 is? Dun, 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 dun. Are we ready for our activity? Or do you want to try example 4 just to make sure you got it?
I think we're good.
Okay. The activity is group work, so that'll be fun. That does not mean that you get to slack off.
Oh, no.
Okay, this says write the segment addition postulate for the points described. Draw a picture to help. So I want to draw a picture first, and then we practiced doing that a minute ago. All right. Draw me a segment. Put dots on the end. Do we need a third point? Yes. Does it matter where it goes?
No.
Okay. Now, what do you think the end point should be? D and P. And what should go in between them?
S.
Look at us go. Now, what does the segment addition postulate say? Look back at your notes. Add them up. Add what up? So DS plus SP must equal what? Boom. Do the rest without me. Go. You can do it. That's basically starting you off on the entire thing. Now, it's group work, so talk to each other about it. Use your words. Does everybody understand? Okay. It says that C is between A and E. For each problem, draw a picture representing the 3 points in the information given. So each time, you're going to have A, E, and then C is in between them. So right now, this is 24. Wait, I'm not done talking. And this is 13. How would you find the full length? Add them together. Would you do the same thing over here?
No, you subtract.
You subtract. Read what it says. Now, finish through 10 tonight. Mañana we'll do some more.